Alright, in this screencast I'm going to show you how to use a Python class that I wrote to interface with the HPC and create a parametric study for an input file based executable, and show you how to kind of streamline your workflow, make it more efficient. I'm logged on to the University of Arkansas HPC right now. This is my terminal window here. I'm in my home directory. I have some directories here. I've created this test study directory to demo my little software. It's called parstubuilder, which stands for parametric study builder. So let's go ahead and inspect. Well, let's change directory to this test directory, test study, and let's look at the contents here. Okay, so the main file that is the software that I wrote is called parstubuilder. So it's this parstubuilder file.py, which you can see listed there. And basically, if you have some kind of job that you want to submit to the HPC, you typically have an input file, which I've called input.dat here. I'm just going to inspect it with Vim here, input.dat. This is for an input file that I use for my research for a code called Meso that Paul Millett research group uses. And so it's got a whole bunch of parameters in here with values. Now when you want to do a parametric study, you typically pick a couple values in your input file. Say here this n stands for number of particles in my simulation. Say I want to vary the number of particles, and I also want to vary this parameter, easy, the electric field strength in the z direction. So I want to run a whole bunch of jobs with different numbers of particles and different electric field strengths so that I can study the relationship between them. So typically that means I need to generate a new input file for each case, and then create a directory, put that input file in there, and then I need to create a batch. I create a job submission script that will submit the job to the HPC, and then run it, collect the output, etc. So if I'm varying two parameters, well, if I'm just varying one parameter, I could just pick one parameter and say I want to change the number of particles, and I could do maybe 10 different values. Well, that's 10 input files, 10 different run scripts that I've got to create. That's not too bad. 10 isn't bad. You could do that manually by hand. But if I want to vary two parameters, each with 10 values, now I've got 100 input files and 100 job submission scripts that I've got to create. And that's starting to get tedious, and you don't want to do that. So that's why I wrote this parstubuilder software to kind of automate all that process away. Okay, so let's leave this. Let's look at the job submission scripts called run.pbs. So let's look at that, vim run.pbs. So I have a PBS script used to submit a job to the HPC. This is the job name. This is the queue, pmillett queue. Some other PBS options. Right now, instead of actually running the executable just for this demo, I'm just saying, hey, print this string here running the executable to this file, and then sleep for 20 seconds, just for demonstration purposes. So now what I want to show you is how I could create a parametric study using the parstubuilder.py code. So I've created a demo. It's called demo.py. We inspect this code, demo.py. What you see here, this is Python code. So if you don't know what Python is, it's a programming language. It's very similar to MATLAB. So this is the code. Import statements is kind of a way to load code from other files. If you don't understand what this means, that's okay. Just go learn about it on the web. So import parstubuilder as PSB. That means in this code, PSB is going to have reference to the parstubuilder code, and OS is another Python module that allows me to run some commands, some OS commands that you would normally run in the terminal. So this first part is all I'm going to do is instantiate an parametric study object. So from the PSB, from the parstubuilder module, there's a class called parametric study. So I'm going to instantiate that, and it's going to take some inputs. You need to give it a study name, and you actually have to type out study name equals and then a string with the study name. I'm just calling the study my demo. You need to give it a path to the study. So that's this os.get CWD. CWD stands for current working directory. So this gets the current working directory from wherever this code is launched. You need to pass it a input file, a default input file, and a default PBS file or job submission script. You can ignore this. This line mod is this is a function that basically says how to modify your input files. So maybe I'll do another video on that a little bit later. But then this is the real important information about the parameter study, parametric info. So here's my parameter. I said I wanted to vary n, and here's the values associated with it. So this is what's called a Python dictionary. On this side, so there's two elements in this Python dictionary. This element right here described on this line, and then there's this element described on this line. So it's two elements. You can see these curly braces kind of define the start and end of the dictionary. So dictionaries always they come in pairs. You have a key and a value. So the parameter name is a string, and it's a key in the dictionary, and then associated with each key is a list of the values that you want to study in your parametric study. So I want n to take on values of 56, 100, 375, and the electric field strength I want to take on values of 0, 12, and 22. So I create this object, my study object, passes this information when it instantiates that object. And now you have this object called my study object, which you can then run its methods to build your parametric study and run it on the HPC. So the build method creates all your directory structure, populates it with all the input files after they've been modified appropriately, and the job submission scripts, and then this method, the HPC execute method, takes one parameter. It says, okay, how many jobs do you want it to submit at once or simultaneously? So I want it to submit 3 jobs, and then submit all the rest of the jobs to only run 3 at a time, taking their turns, so that you don't use up all the nodes in your queue if you don't want to. So anyways, so that's what this script does. This script is called demo.py. So all I need to do is use Python to execute this script, and it'll build my study for me and submit it to the HPC. So let's go ahead and give it a try. So if you're not familiar with modules on the HPC, modules are like software that's available on the HPC. I've got these modules loaded. You need this Python module right here in order to run this script. So if you don't have it, I'm going to unload it. Module, unload, Python. Now I can do module list to see which modules I have loaded. You can see I don't have it. It's not showing up in this list. So now let's add it. Module load, Python, module list. You can see now I've got it, Python 2.7.5. Okay, now I can run this. So to run it, I just type Python, and then the name of the script, which is demo.py, and it's going to run. Okay, it ran. Now I can look at my queue. I have some custom scripts. MJS stands for my job status. It just shows me what job's running on the HPC. According to this, I've got 3 running jobs here, and their names: EZ0, N56, EZ0, N100, EZ0, N375. So those 3 jobs were the first 3 jobs from my parametric study. So if I just list the contents of this directory now I've got this my demo directory. If I look in the contents of that, ls my demo, I see all these directories that have been created, and inside each of those directories, ls my demo, let's just look at one, EZ0 N100. It's got the input files, the run script, and this one's already finished. So look at, if I look at, oh look, there's only 3 jobs running left. So 6 of them have finished, 3 of them are still running. That's because I'm just sleeping for 20 seconds. These ones are probably, okay, they're running. Anyways, so you see, you can create a parametric study with any number of parameters, with any number of values for each parameter, and quite quickly generate all the files you need and submit those job scripts to the HPC just really quickly. So last thing I kind of want to show is what happens if, okay, say your jobs aren't going to run for 20 seconds. They're going to run for, I don't know, however long your jobs take to run. And usually it's, an hour to anywhere from an hour to a couple of weeks. I have jobs that do both. But let's say you submit some jobs and you submit 200 jobs because you're doing a very big parametric study. And now you realize that you screwed something up and one of the parameters was wrong and you need to change it. So you need to go ahead and delete all your jobs. What do? Well, this parstubuilder class module and parametric study class has a nice method for doing batch delete of all your jobs. So what happens is when you create the study, creates this directory, the study name, and inside my demo, remember it's got all these studies, but also saves a little file here called job IDs. If you look at that, cat job IDs, it's got the job numbers of all the jobs that were submitted. So one thing you can do is you can just write a little Python script that will kill all the jobs. So I've done that. Here, I guess I need to go back to the main directory. So if you look here, I've written this script called my demo kill jobs. So if I look at that, then my demo kill jobs, all it does is it imports parstubuilder as PSB and instantiates a parametric study object. And instead of giving it all the different input parameters that we did before, I just give it the name. And the name has to match the name of the study that you created. And then after I do that, I just run the bash delete method on this object, and it'll go ahead and delete all the jobs. So let me demo that. So let's quit this. I'm going to go ahead and remove the my demo directory, delete all that stuff, because I'm going to restart it. So let's go ahead and restart again. Python demo.py. Alright, now I've got 9 jobs running again. Now let's say I want to delete them all. I can just type Python my demo kill jobs, and it goes in and it kills all the jobs. So now I can look, I have no jobs running. So, and it's handy, it even works if some of the jobs have finished. So let's start it again. So Python my demo, no, Python demo.py. Start this. So I got my jobs, and we gotta wait like 20 seconds. Let's see. Well, they're still queued. Okay, now they're running. We should wait about 20 seconds, and then we'll see that these 3 jobs finish. And then we'll still be able to delete the rest of the jobs using that script. So let's see. Oh, still running. Should be done soon. Oh, there we go. They're done now. Okay, so now some of them finished, but some of them haven't. Let's still kill it. So let's run the Python my demo kill jobs.py. So you see it tries to delete this job, and there's an error because the job doesn't exist anymore, but it just skips over those, and eventually it gets to the jobs that are still running, and it deletes the rest of those. Now you can see I have no more jobs running. So that's it. That's how it works. Hopefully that was clear. Now you can get this demo and the parstubuilder.py code. So remember, I said you need this code, parstubuilder.py, and all you have to do is remember to put your default input file in the folder and your default run PBS folder in the same place as the parstubuilder.py. Then you can use this and build it. So if you want to get all these files here, this parstubuilder is on GitHub. This is my profile. If you come here to the repositories, you can go to parstubuilder. You just need to go to the develop branch, because I have plans for this. I'm going to try and make it better. But you can come to the develop branch. So go to GitHub, go to my page, go to the parstubuilder repository, and then there's this little button called branch. Click on here. It says master. Go to the develop branch right here, and that'll take you to the code. Here's the code. All you have to do is click on this clone or download. If you're not familiar with GitHub, just download this. It downloads a zip file, and you can unzip it, and you can stick it on your each PC account, stick it up in your home directory or something, and then move it around and use it. Let's see. Anything else I need to tell you? I don't think so. I think that's just about it. If you're familiar with Git and GitHub, you can fork the code, or you can just clone it. I hope to make it a little bit nicer, add some actual documentation and stuff to it later. We'll see how much time I have. But anyways, hopefully that allows you to use it, and this will be the end of my video. So I'm going to go ahead and end this, and we'll see you sometime later.